Myself, Kunjamina are doing PG in Department of Chemistry, University of Kerala, Kalyotam campus. In this video, I would like to say about Nobel Prize awarded for Chemistry 2022. The Nobel Prize in Chemistry awarded to three scientists, Caroline R. Bertozzi, Morton Meldal, and K. Barry Sharpless, for their work in snapping molecules together. Their work honored for their advances in click chemistry, which has played a major role in treating and diagnosing illness. Caroline A. Bartossi of Stanford University, Morten Meldal of University of Copenhagen, and K. Barry Sharpless of Scripps Research will share the prize of 10 million Swedish kroner, which honor the scientist independent research, which has resulted in development of what is known as click chemistry and bioorthogonal chemistry. Their work have led to a revolution of how chemists think about linking molecules together, said Johann Aquist, the chair of Nobel Committee for Chemistry. In winning the Nobel Prize in Chemistry 2022, Dr. Sharpless became only the fifth person to win two Nobels, having received Nobel Prize in Chemistry 2001 for his work on chirally catalyzed oxidation reactions. Bertozzi also became the eighth woman to be awarded for the chemistry prize. We know that molecules are reacting all around us. These reactions can produce new molecules, breaking down of old ones and allow energy swap, thus shaping different dynamics of universe. For scientists looking to understand such forces, combining these molecules in a controlled way is difficult, especially in a delicate environment like living cells, because everything is so closely connected. In 2001, Dr. Sharpless and some of his colleagues published a paper introducing what he called click chemistry, a new way of approaching this kind of molecular force when applied to creation of new drug compounds. The method was based on the fact that all searches must be restricted to molecules that are easy to make. That means instead of trying to synthesize molecules by forcing difficult organic bond, focus on the bond that form fast and produce stable byproduct. If done in the right way, the tougher bond will form automatically clicking into place. What's unique about click chemistry is that the two reagents in presence of hundreds or thousands of different types of molecules, they will only seek out each other and will produce only one product, which is the basis of all of this technical development. This shift in approach was soon followed by discovery of a reaction known as copper catalyzed azide alkyne cycloaddition reaction, which put the theory into practice. When azides combine with alkynes in presence of copper, the reaction occurs faster and efficiently and produce much stable product. As a result, this reaction is globally used to link molecules together in a simple manner. John Lodge, the director of National Institute of General Medical Science, quoted that click chemistry allows to resemble molecules in a fairly defined way, such that one can direct what's attached to what easily. The most pivotal application of click chemistry began to take shape before the term was coined. In 1990, Dr. Bertozzi, studying the glycans, the carbohydrates that sit on the surface of proteins and cells, the function of which were not wholly understood. It was really difficult to track these glycans inside the living organisms. Dr. Bartossi began to take new way to attach fluorescent molecules to these glycans so that she could map them as they move. But the molecules that used to track these glycans could not interfere with the rest of cells functioning. So the method had to be, as Dr. Bartossi put it, bioorthogonal. About the same time that click chemistry emerged, Dr. Bartossi was able to develop bioorthogonal tracking methods. She could realize that she can apply new pattern to her work, that is attaching fluorescent alkynes to glycans to be tracked. As copper the catalyst, which is toxic to living organisms, Dr. Bartossi came up with a different way of two molecules to click together, modifying the alkyne structure to fulfill the catalyst role. What she did was recognize and apply the concept to the reactions that would involve in biological systems. So the application of click chemistry involved modification of peptide function with triazoles, modification of natural products and pharmaceuticals in drug delivery, in polymer chemistry, etc. So the field of click chemistry is still in its early phase, and which has opened up an immense amount of new space to study how different processes work. So I hope you all understood something about click chemistry and bioorthogonal chemistry. I'm concluding my video. Thank you.